Hello friends, welcome once more to class online. My name is Mr. Dami, and in this edition we shall be looking at Jamb mathematics under the following topics: matrix, logarithm, and variation. And we shall be having a very nice time in this third edition. Don't forget that I said that every topic in mathematics carry equal mark, and that means that every topic should be treated with equal importance. That means that these topics that we are going to look at today must be well addressed and must be treated with the same importance you would have given to every topic in mathematics. So therefore, we shall be looking at different years in matrix, in logarithm, and in variation. So let's begin with matrix. Matrix singular, matrices plural. Now, first year we went through a year and we found a year that had this question. P equals P is a 2 by 2 matrix of 5, 3, 2, 1, and Q is a 2 by 2 matrix 4, 2, 3, 5. Find 2P plus Q. 2P means 2 times P, so I just did 2 brackets. Since P is this, is 5, 3, 2, 1, so it will become 2 brackets 5, 3, 2, 1 plus Q is 4, 2, 3, 5, and that's what I have here. Now 2 bracket means 2 times, so 2 times this is 2 times 5 is 10, 2 times each time, 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2, plus 4, 2, 3, 5. Now when you plus together, you are, to plus matrix, you must plus matrices that are on the same side. So 10 is on the same side with 4, so that becomes 10 plus 4, and that's what I have here. Then 6 is on the same side with 2, that becomes 6 plus 2. Then 4 is on the same side with 3, 4 plus 3. Then 2 is on the same side with 5, 2 plus 5, and that will give me 14. 10 plus 4 is 14. 6 plus 2 is 8. 4 plus 3 is 7. And 2 plus 5 is 7. So the answer to that question is D. Let's check the second half now. Now this one means, now this symbol, this bar means determinant of the matrix. Now how do you find the determinant of a 2 by 2 matrix? Just multiply. It's like you are cross multiplying x times 7. Like this is it here. I just did this. I cross it like this. I cross multiply it like this. That will come x times 7, and that's x times 7. That's 7x. Then 2 times 3, and that becomes 6 equals 15. Can you see that? I did a cross multiplication. 7 times x, that's 7x. 2 times 3, that's 6. But I put a minus in between. You see, there must be a minus in between all the time. So it will be 7x minus 6 equals 15. That's how to find the determinant. Just cross multiply and put a minus in between, and that is the meaning of determinant of a 2 by 2 matrix. And that's what we have here. 7x minus 6 equals 15. Then the 6 will go over collecting like terms. Now becomes 7x equals 15 plus 6, which is 21. Dividing by 7, dividing both sides by 7, x is equal to 21 over 7, which is 3. And that is my answer for that. Now this is this bar means determinant of, but this matrix is a 3 by 3 matrix. Now to find the determinant of a 3 by 3 matrix is a little bit higher. So what you do, first of all, pick out the first terms. Here on top here is 4, put out the 4. Then on top here is 2, put out the 2, but don't write the 2, put a negative sign in the second one. Now please take note, what is here is 2. But what did I put here? I put a minus 2 because you must include a negative sign. You mustn't forget, it must have a negative sign. Then the last one will be normally minus 1. I didn't add a negative sign. If I've added, it will have become plus 1. Negative and negative is plus. But actually, you must add a negative sign, so only the middle one. Please take note. Please take note. And that's what I have here, 4 minus 2 minus 1. Then pick out the cofactors, the ones that are not under the 4. Now this is 4. These are the column of 4, 2 and minus 1. These are the row of 4, 2 and minus 1. The ones that are not under the row and the column of 4 are 3, minus 1, 1, 3. And those are the cofactor of 4. 3 minus 1, 1, 3. Then under the 2, this is the rule of 2 going down. Don't use any of these numbers on the row. Don't use any of this number on the column, sorry. Then don't use any of this number on the row. So that means you are going, these ones here are cancelled for 2. Then these ones here are cancelled. So you'll be using 2, minus 1, and 3. Those are the cofactors of minus 2. The last one is minus 1. Don't use the one under the same column. Don't use the one under the same row. Use the ones that are not there. That's 2, 3, minus 1, 1. And that's what we have in this place. And that's what we have around. Then what we do, find the determinant of the 2 by 2 matrix below. And that will become 3 times 3. You know the way I did it before. I will multiply 3 times 3 is 3 times 3, then 1 times minus 1, and that will become minus 1 minus 1 times 1. You know, this is, it will be 3 times 3, then there will be a minus naturally. So 3 times 3, then there will be a minus naturally, minus 1 times 1, and that's what I have here, minus 1 times 1. Okay, then the next one is minus 2 itself, then minus 2 itself, then I have 2 times 3, and that's what I have here, minus, then the 2 guys here are minus, so it will become minus 1 times minus 1, and that's what I have here. Then minus 1 itself, then 2 times 1, then minus naturally, then 3 times minus 1, and that's what I have here. And then if you solve further, you'll be getting 4 in bracket, 3 times 3 is 9, minus 1 times 1 is minus 1. Can you see that? In bracket close. Minus 2 times 3, that's 6. Then minus 1 is plus 1, and that's 1 here. Can you see that? Then minus 1, bracket 2 times 1 is 2. Okay. Minus 3 times minus 1 is minus 3. So minus and minus jam, that will give me plus, and that's what I have here. So I have 4, 9 minus 1, minus is plus, and that will become 9 plus 1, which is 10, minus 2, bracket 6 minus 1 is 5, minus 1, bracket 2 plus 3 is 5. That's what I have there. So 4 times 10 is 40, minus 2 times 5 is 10, minus 1 times 5 is 5. 40 minus 10 is 30, 30 minus 5 is 25, and that's the answer, 25. Next one is the inverse of a matrix. You can see this symbol minus 1 raised to the power minus 1 means inverse. Now, how do we find inverse? The formula for inverse is 1 over determinant times transpose. Now, that means you need to find determinant of this matrix, then find the transpose and plug it into this formula to find the inverse. Now, look at this now. We have how do we find the determinant of this matrix? It's very easy. We've done it before. So we have 2 times 1, just multiply, cross multiply. 2 times 1 is 2, then minus, put a minus in between, then 1 times minus 3 is minus 3. So, but that's minus 3 times 1, there's a minus in between. So if you say minus 3 times 1 is minus 3 and minus is plus 3, because 2 minus make a positive. So 2 plus 3 is actually 5, and that is the determinant of the matrix. But we need to find the transpose also. Now, what is the transpose? Now, this is the matrix again. Transpose means change the column to the row and the row to the column. So this is column. Minus 3 and 1 are column. Change them to row. That will become minus 1 and 3. Then 2 and 1 are column. Change them to row. It will become 1 and 2. Right? Now, can you notice that the sign also change? In this one 3 is negative, but in this one 3 is negative. In the first one, all this number 2, 1, 1, they are all positive, but here they are all negative. So I changed the row to the column, but not only that, I also changed the sign. Can you see the way I changed it? That's actually what should be done, and that's what we have here. And this is the transpose. Now plug everything into the formula, determinant and transpose. So I have this is the formula for inverse of matrix. 1 over determinant of P and transpose of P. So the determinant is 5. So that will become 1 over 5 below. Then transpose is, the answer to the transpose is what I have here. And that's just it. Then multiply each term by 1 over 5. That will become 1 over 5 minus 1 over 5. Then 1 over 5 times 3, 3 over 5. 1 over 5 times minus 1, that will become minus 1 over 5. Well, 1 over 5 times minus 2 over 5. And that is the answer to that question. Okay, so that's just it. Then the last one is a 3 by 3 matrix, but it's a unit matrix of the order of 3, and that means that the matrix is like this. Unit matrix means it has only number 1 on its diagonal. 1 on the diagonal. The unit means 1. It has only 1 on the diagonal. Diagonal means this straight line. So every other place must be 0. But for it to have been a unit matrix of the order of 3, that means it is 3 by 3 matrix, but it has only 1 on its diagonal, and that's what this means. Unit matrix of this order, 1 1 1, then 0 0 0 0, so 0 on the other part, and that's what I have here. The next thing is for me to find the determinant. Remember that I said that the determinant of matrix, you have to pick up the first number 1, then the ones that are not on the same column and on the same row are actually for this number 1 and look at these ones are cancelled because they are on the same column. These ones are cancelled because they are on the same row. So I'm left with 1 0 0 1. So cross multiply, 1 times 1 is 1, then minus 0 times 0 is 0, then minus the second one 0. Now these ones on the same row column are cancelled. This one on the same row are cancelled. I'm left with 0 times 1, which is 0, then 0 times 0, which is 0. So minusing them, this is gone. Third one is the one on the same column are cancelled. The one here are cancelled. So I'm left with 0 times 0, that's 0, then 0 times 1 is 0. So solving this one, all these ones are 0, these ones are 0. The only one that's sensible here is this one. So 1 minus 0 is 1. 1 times 1 is 1. And the answer is there for 1. So the answer is 1. Now the last one on this matrix is a find the value of x. We have this determinant of this, determinant of this. How do you find the determinant of a 2 by 2 matrix? You just cross multiply. 5 times 2 is 10, then 3 times x is 3x minus 3x. So equals 3 times 5, 15, minus 4 times 5 is 20. So 15 minus 20 is minus 5, 10 minus 3x. Then we have minus 3x is equals to minus 5. The 10 here we jump to the other side and become minus 10. So that will become minus 3x equals minus 15. Minus cancel minus divided by 3, x is equal to 15 over 3, which is 5. So the answer is just 5. Let's talk about logarithm right now. Now we pick a question from the years in logarithm. This question, I chose this question because it will help to show you most of the laws of logarithm and to remind you. So now we have the first law of logarithm says that anything addition will become multiplication and anything subtraction will become a division. So we have this now. We have log 2 8 plus log 2 6 minus log 2 4. So it will become, this plus will make it times. So it will become, since log 2 is common, it will become log 2 bracket 8 times 16 divided by 4. Notice plus became times, minus became division. So 8 times 16 is 128 divided by 4. 128 divided by 4 is 32. So that's what I have there. Then we make it into power. The power of 32 is 2 to the power 5. How did I get that? Do it like LCM. 32 divided by 2, 16 by 2, 8 by 2, 4 by 2, 2. So it will give you 2 in 5 places. That's 2 times 2 times 2 times 2 times 2. That's what I get for 32 in power form. And you know that just like 16 is 2 raised to the power 4, and 8 is 2 raised to the power 3, and 4 is 2 raised to the power 2, and 64 is 2 raised to the power 6. So you must be conversant with the conversion of numbers to power. And that's what I have here. 32 is 2 raised to the power 5. And then I've made it into power form. This power 5 will go to the front. It will become 5 log 2 2. Because in logarithm, there's a law that says that anything power will come to the front of the logarithm. So we have raised to the power 5. The 5 will come to the front. 5 log 2 2. And there's another law that says that whenever the numbers are the same, it will become 1. It will become 5 times 1. Log 2 2 is 1. 5 times 1, because they are the same. So even if it is log 10 10, it will become 1. Because if logarithm are the same, if the logarithm is the same with the base number, it will become 1, and that's the law. So we have 5 log 5 times 1 is actually 5, because log 2 2 is 1. So it will become 5 times 1, which is 5, and that's the answer for that. Then we have log 3 18 plus log 3 3 minus log 3x equals 3. Now this is actually, see, the same law applies. Plus and minus. Plus will become times and minus will become division. So I have log 3 bracket 18 times 3 over x equals 3. Then that will give me what? That will give me 54. 18 times 3 is 54 over x equals 3 raised to the power 3. How did I get that? I removed this 3 from here and took it to the other side, and when I do that, the logarithm will die. Now, there's one law that says that the way to eliminate logarithm, to remove logarithm, is to remove the base number of logarithm, take it to the other side, and make it a base number at the other side for the number at the other side. That means I'll just take, so if I have log AB equals m, if the a goes to the other side, it will become b equals a raised to the power m. Then where's logarithm? Logarithm is gone. That's how to convert logarithm into indices. And that's what I did here. So I removed this 3 from here, took it to the other side to become the base number. So the 3 went to the other side to lift up this 3 at the other side, and that removed the logarithm automatically. That is the way to eliminate logarithm and make logarithm into indices, and that's what I did here. So I have 8 times 3 is 54 over x. This 3 here is this 3 here. It went down here to lift up the 3 over at the other side, and that's the way it is done. So then you have 54 over x equals 3 raised to the power 3 is 27 over 1, right? It's actually 27, so I just made it fractional by putting over 1. Cross multiply, that will become 27x equals 54. Divided by 27, I have x is equal to 54 over 27, which is 2. So my answer to that question is B, is 2. Now the last one in logarithm, log 112 is actually log 16 times 7. You have to break down the number into 2. 16 times 7. Now that's it. Then this is log 2 and log 7. Now they said I solve it, so they've given me log 2 and log 7. Now they are not expecting me to use a calculator. So first of all, the number has to be broken down into 16 times 7. How did I get that? Because I've seen log 7 is here, so I know that it has to do with what? Something that has to do with 7 and 2, right? So I'm thinking of how will I get 112? It is actually 16 times 7 that will form 112, and I knew because I was given log 7. So it will become 16 times 7, then break it further, times will become plus log 16 plus log 7, right? Now 16 is actually in power form, is 2 raised to the power 4. So the 4 on the power form will go to the front, it will become 4 log 2 plus log 7. You can see that I have gotten my log 2 and my log 7 finally. So all I was trying to do was to bring the work to log 2 and log 7, because I was giving the answer for log 2 and log 7 only. So that means whatever I'm doing here must come to log 2 and log 7. And that's what I have here. So we have 4 brackets. What's log 2? 0.3010. And that's what I have here. Plus log 7, 0.8451. And that will give me what? 4 times this is going to give me 1.2040. Then this is 0.48451. If you plus, you will get 2.0491. And that is your answer. And that is it for that. Then we have the last one on logarithm. Log 8 10 equals x. So we have log 8. 10 is 5 times 2. I broke it down, equals 10. And they said evaluate log 85 in terms of x. So that means you mustn't solve log 85. It must remain as log 85. So it will become log 85 plus log 82 equals 10. I broke it down because of times will become plus log 85 plus log 82 equals 10. So I'll solve only log 82. I won't solve log 85 because it is what I'm supposed to evaluate. And that's what I have here. So log 85 is equals to log 82 will now become, the 8 can be made into a power form, 2 raised to the power 3, but because it is under the logarithm, the power will come to the back, but it will come inverted. It will become log 85 plus this 3 here on power will come to the back here as 1 over 3, not 3. Please take note, it must be 1 over 3, not 3, because it is not 2. It is not a base number, it is under the logarithm. So when it comes to the back, it's not like when this 2 has a power. When this 2 has a power, it will come to the back as normal number. But if it is the logarithm that has a power, it will come to the back inverted. That means having 1 over. And that's what I have here. 1 over 3 log 22 equals x. Log 22 is the same, it will become 1. So it will become 1 over 3, 1. Notice I didn't touch this. I left it like that because I'm to evaluate log 85 itself. So that's what I have here. 1 over 3 times 1 is 1 over 3. So it is log 85 plus 1 over 3 equals f. The 1 over 3 will go to the other side. It will become log 85 equals s minus 1 over 3. And that is the answer to the question. That makes the answer C. And that's that for that on logarithm. Let's talk about variation. Now, if y varies directly as w squared, that means direct variation is a symbol. This means direct variation. Y is directly variable to w squared, right? Now it will become equals to kw squared. Can you see that the symbol of direct variation will become equals to this symbol will become equals to k. Please take note, it will become mathematically equals to k. Please take note, this equals to k came from this symbol, so it will become y equals to kw squared, right? Now to find, your next step is to find k. So make k the subject. So this w squared will go under the y. It will become y is equals to kw squared. Dividing both sides by w squared. Cancel. W squared is under here. So k is equal to y over w squared. Can you see that? The next thing is going to become, what's my y? My y is 8 in the question. My w is 2 squared, right? Giving me 8 over 2 squared is 4. 8 over 4 is actually 2. So my k is 2. Can you see that? So my k actually is 2. Then it said find y when k when w is 3. So look for a formula that asks y equals wk kw square. So recall that y is equal to kw square. So plug in the value of k. What's the value for k? 2. My new w is actually 3 squared, and that's it. So I'm finding y, right? So that will become k is 2, w is 3 squared, which is 3 times 3, which is 9. 2 times 9 is 18. So my y is 18 when w is 3, and that's the answer to that question. Next one, p varies directly as q and inversely as r. Now this is actually direct variation. P varies directly as q. This is the symbol. P varies inverse variation is 1 over. It must have a 1 over. 1 over is the inverse. So p varies inversely is 1 over r. Can you see that? Now combine both, it will become p varies directly as q and inversely as r. Can you see the symbol? And this symbol of variation must change to equals to k. It will become p equals to k q over r. Can you see that? Then that's just it. Now we have to find what? Make k the subject, so you cross multiply kq equals pr, and dividing both sides by q, it will become k equals to, dividing by q, q cancel q come under here, k is equals to pr over q. So k is equal to pr over q, and that is what you will get there. Now plug in the values. You are given q as 36, r as 16, and p as 27. So what's my p? 27 times r 16 over q 36. Now cut it out. 9 here 3, 9 in 36 is 4, 4 here 1, 4 in 16 is 4. So 3 times 4 is 12. So my k is 12, and that's my value. So the relationship between p, q, r means what is the value of k, and that means k. So the relationship is what I have here when I have it here, and that's what I have here. P equals that's relationship is when you first discover k, and that's p equals kq over r. So you have gotten your k as 12, so it will become p is equals to kq over r. It will become p is equal to 12q over r, and that is the relationship between them, and that is the end of this question. Next question is actually p is directly variable as mu, and that's actually joint. So p varies jointly as m and u. Can you see the joint variation? It's actually direct variation of two variables. So p is directly variable as mu, that's joint variation. Then it varies inversely as q. So p varies inversely as q. If you combine both, you'll be getting p varies directly as mu over q. Can you see that? Now that will become this direct variation. So this variation sign will change to equals to k. P is equals to k mu over q. Can you see that? Then make k the subject. If you cross multiply, kmu is equals to pq. Then that will give me dividing both sides by mu, it will come under here. K is equals to pq over mu, and that's my answer for that. Then plug in the value for pq mu. My p is 4, my q is 1 over, my m is 3, my u is 2. 4 times 1 is 4, 3 times 2 is 6. And that will give you, if you divide by 2, you get 2 over 3 as your answer. So my k is 2 over 3. So it will give me, for this formula that I got here, it will become p is equals to 2 over 3 mu over q. That is where the k was standing when you first formed it. And that's where what you have here. P is equals to mu, 2 over 3 mu over 3. But you were, over q, sorry. But you were also given to find p. Haven't been given another m, u, and q. So plug in the new m, u, and q. My new m in the question is 6. Then my new u is 4. My new q is 8 over 5. Now solving this fraction and fraction. These 3 on the fraction above will come down. This 5 on the fraction below will go up. It will become 5 times 6 times 4 times 5 over the 3 that came down, 3 times 8, which is below. And that's what I have here. Now cut. 2 here 1. 2 in 8 is 4. 4 cancel 4. And I'm left with 3 here 1. 3 in 6 is 2. So I'm left with 2 times 5, which is 2 times 5, which is 10. And that's my answer for that question. My p will become 10. And that's that for that on variation. Now the last question in variation, we have r varies inversely as the square root of s, and t. How does s vary with r and t? Okay, so we have r varies inversely. Inverse variation is 1 over square root of s and t. That's root st, and that's what I have here. So that will give me what? That will become varies inversely as root st. Now that means this question is saying how does s, that means find s using R and T. So my goal is to change this into to make S the subject of formula. So this symbol of variation will change into equals to K. But because there was no mention of relationship in this question, I will not put a constant K. I'll just use that K as a constant of 1. And that will become R equals to 1 over root ST. Okay, now to make S the subject means I must now begin by cross multiplying. So R root ST equals 1. Then remove everything from S and let the S stand alone. So the this R will go under to the other side, and that will become root ST equals to 1 over R. Okay, and that will give me that, and then this root will go to the other side. It will become ST is equals to 1 over R all squared, because when root goes to the other side, it becomes squared. Then if you plug in the square to each term in the fraction, it will become ST is equal to 1 square over R square. 1 square itself is 1 over R square. So S is equal to 1 over R square, right? Then you are finding what you are looking for. Actually, you are trying to make S, so you have to remove T, cancel the T. ST over T equals 1 over R square. So dividing by T, T cancel T, the T will come over here. It will become S is directly proportional to 1 over TR squared. Okay, and that makes the answer to become D, because this symbol is actually, it's not even directly proportional, it is inverse, because you can see 1 over. 1 over means inverse. There it is S varies inversely as T and R squared. So it will become S varies inversely as R squared and T. That is D is the correct answer. And that brings us to the end of this session. Don't forget that a practice quiz has been sent to the classroom. You can do it to check it out. And also, if you have any questions, you can comment me or ask on the classroom. I would like to hear from you. Until we see again, guys, take care of yourself and bye for now.